Writing a journal paper and getting it published in the reputed journal is a very important part of a researcher. So if we are doing a research or a part of a PhD program, it is not only important that we do good research, but at the same time, it's very important that we publish our work. So it is said that if we don't publish, we will perish. So it is very important that we publish our work. However, writing a good paper requires quality time investment, and the skills required doesn't come automatically. There are many people who are very good researchers, but when it comes to present their work in writing, they struggle. So in this presentation, we'll try to see how to write a good journal paper. I'm Nijwm Wary, Assistant Professor at School of Electrical Science, IIT Bhubaneswar. So in this presentation, we'll first start by looking into the journal review process. Then we'll take two IEEE journals as an example and discuss in details the various parts and the contents of a journal, such as the title, abstract, introduction, etc. Then we'll discuss different do's and different don'ts that we should take care while writing a journal paper. And finally, we'll discuss some of the important writing tips. So let's get started. So these are the two IEEE journal papers which we'll take as an example while discussing the different parts of a paper. One is from the IEEE Journal of Solid State Circuits. Another is the IEEE transaction on VLSI. So let's first start by discussing the review process. So we as an author will send our manuscript to the editor, or who is sometimes called as editor-in-chief. The editor-in-chief will send the manuscript to the associate editor. So there are multiple associate editors in a journal who are experts in different specialization. So the editor will send our manuscript to particular associate editor who is expert in that field. Then the associate editor will send our manuscript to multiple reviewers, at least two, to review our paper. Usually the reviewers is three or more. The reviewers will be given few weeks to review our manuscript, and then they will send their comments and feedback to the associate editor. And the associate editor, along with the editor-in-chief, will take a decision and convey it back to the author. Or sometimes the associate editor will directly convey the decision to the author. There are different types of decisions an author receives in the first submission. So the type of decisions can be accept with revision, reject, or refer to another journal. So let's discuss it one by one. So first is accept with revision. So the accept with revision can have two types. One is the major revision and the other is the minor revision. So when it is major revision, we should know that the paper is not yet accepted. This is still a 50-50 situation. We need to address the query of the reviewers before it is accepted. In this case, the author rewrites the paper based on the reviewer comments and send it back to the editor. Generally, the associate editor arranges second round review by sending the edited manuscripts back to the reviewers. The other type of this decision is minor revision. So if it is a minor revision, congratulations, you are almost there. So it's almost accepted, or it is, you can say that it's accepted. But still we need to give importance to the reviewer comments and respond them sincerely. Refer to other journal. So this decision comes whenever the research work is not related to the journal scope of work or the area of research. So then the editor will ask us to submit to another journal. And the third type of decision can be reject. So of course we should not worry if we are rejected. We can always try to understand why it was rejected based on the reviewer's comments. And based on the comments, we can try to modify our paper and try to submit it to another journal. So we'll discuss the 3 R's before we write a journal. So what are these 3 R's? These 3 R's are very simple. It is just read, read, read before we write. So we need to read good papers before we write our journal. I have mentioned 3 reads because we should have at least 3 good sample papers which are our ideal and which we want to follow them. So we want to follow them in terms of the writing style, drawing figures, presentation, flow, etc., etc. Of course, we can have definitely more than three, but here I am telling that at least it should be three. The next important point is no shortcuts. So there are no shortcuts if we really want to publish a good journal. We have to go through multiple iterations or revision before we can come to the final version of the manuscript, which is ready for submission. And we have to revise the manuscript again and again till the time there is no mistakes that is visible to us. So these are the printouts of the manuscripts, the multiple printouts which I gave to my supervisor for getting it edited. So before I had finally submitted and got it accepted in the IEEE Journal of Solid State Circuits. And of course, it's not just me. Anyone who has got their work published must have done this one. So this is the actual reality. So this is what we see in a paper, but this is the actual effort an author gives to get his manuscript accepted. And of course, this illustration is not to scare us. This is not to scare us, but to remove our fears. So when we read a good paper, we feel nervous thinking that we'll never be able to do that. But we have to understand that it's not a one-day job. There is a saying, right? Rome was not built in a day. So the authors must have invested so much time to come to this point, and we should feel the confident that if we invest similar time and energy, we will also be able to do it. Writing a paper is like building a house. So when we are building a house, we first start with making the plan, making the outline using pen and paper. Then we start slowly building the structure, and after that we start slowly filling the details and designing the interiors. We start designing the doors, start putting the glasses, lights and paintings. So this is a step-by-step procedure. When we are in second stage, when we are doing the structure, we are not worried about the paintings or where we should put the furnitures, where we should put the light. Similarly is the paper writing. First we have to plan for every sections, and then slowly we should start filling the details, and eventually we should make the paper grammatically correct. So when we are in second stage, when we are trying to fill the details, we should not be too much worried about the grammar. If we try to make the paper perfect from the first day or from the first draft, we will never be able to make it. Before we actually start on how should we start writing a paper, let us try to discuss the different parts of a paper. So these are the outlines of a paper. We have the title of the paper, we have the abstract, we have the introduction, and that is followed by the body of the paper, and the body of the paper is followed by the results section, and then results section is followed by the discussions, and ultimately we have the conclusions and the references. So let us start by discussing the title of the paper. So that the title of the paper is basically the whatever is written on the top. So these are some of the attributes of the title of the paper. The title should not be vague. It should be specific, describing the paper. Let's get some examples which are not very clear or which are not very specific. So, for example, a novel operational amplifier design in 180 nanometer CMOS. So here we can get hundreds of design of operational amplifier which are designed in 180 nanometer. So which are not very specific. The other example can be CMOS low power design technique for ADC. Here also we'll get hundreds of papers which discusses about the CMOS low power design technique for an ADC. So these are not very specific title. This doesn't describe the work very specifically. So this is an example which I have taken from one of the reputed journal. So the title is a 13-bit 0.005 mm square 40 megasamples per second SAR ADC with KT by C noise cancellation. So here it's very specific. It's describing the number of bits, the area occupied by the ADC, the type of ADC, the sampling rate, and of course with KT by C noise cancellation. This has provided a very specific details of the proposed ADC. We can also write the title without being too specific to the numbers. For example, a low noise chopper amplifier designed for multi-channel neural signal acquisition. So here it's describing the type of the amplifier and also the applications, which is multi-channel neural signal acquisition. So these are two good titles that we can follow. After the title, next thing comes is the abstract. So the abstract is the portion which is the first paragraph of a paper. The paper starts with the abstract. So these are the attributes of an abstract. So it should be just one paragraph. It's like a trailer of a movie or an advertisement. So just like by seeing a trailer of a movie, we want to see the movie. Similarly, by reading the abstract, anyone should be interested to read the whole paper. So it should describe exactly about the paper. It should be nothing more or nothing less. We should not put any references in the abstract section. It can have an overlap with the conclusion, but of course it's not the same. So after the abstract we have is the introduction section. So the introduction section starts by describing the area of research and the problem we are trying to solve. So for example, in this paper is basically focused on trying to solve the problem of on-chip interconnects for network on chip. So it described this problem in the first paragraph. The next is describing the state of art work by giving plenty of references. For example, in this work, references from 1 to 21 has been cited briefly in this section describing the different works in this area. The next section describing the issues in the current techniques or the solution. So we should start the next section by describing the issues in the current techniques and solutions. So basically this section is trying to say that okay, these techniques are existing, but still there is some scope of work or there is some loopholes or there is some gaps that we can try to fill. So once this is done, then we can introduce our work and our idea by briefly explaining how it is different from others and also giving an outline. So basically this section will motivate the readers to continue. So this is a section where we briefly explain our work and gives an outline. So the next section is the body of the paper. We should start it by explaining our basic idea. So it should be as simple to understand and a good figure will definitely help. So it should be very simple to understand for the people to follow, because by this people will get motivated to read our whole paper. So in my paper I have shown these two diagrams basically. So this is the conventional technique and this is the proposed one. So the main difference, what I tried to highlight was this subtraction and addition. So because of using this subtraction procedure, this technique had a trade-off, and simply by replacing the subtraction with addition, I could remove the trade-off. And of course, in later part of the paper, we had described how this addition is not so easy and how it has to be taken care by using some intelligent circuits. So this part of the paper can be simple to understand so that people can appreciate our contribution and would like to learn our work more in details. We need to build up the idea of the work step by step. So one thought at a time. Each thought or step should be in one paragraph. So if possible, we should use mathematics to prove the idea and convince the reader that it makes sense. So mathematics helps a lot in this section. For example, I have used a very rough mathematics to compare the power of the proposed technique and the conventional technique. So this is the comparison equation where I have compared the power consumed by the proposed technique and the conventional technique. So this is like saying if I have a $10 and I want to buy mangoes, and if I have two options, either to go to shop A or shop B. Now I don't know whether to go to shop A or shop B. So I ask my friends whether to go to shop A and shop B. So my friend says that if I go to shop A, I'll get two mangoes. Whereas if I go to SOP B, I will get 4 mangoes. So it is very clear here that the SOP B is 2 times greater than SOP A. But when I actually go to SOP, so when we go to SOP B, actually we'll see that we are not just buying 4 mangoes, we may be saving $1 more. So we can say that SOP B is greater than SOP A even more than 2 times, right? So instead of just plainly saying that SOP B is better than SOP A, it's much better to say that SOP B is approximately X times better than SOP A. So we can use the mathematics to convey this point. So this X may be, okay, when we are doing the initial comparison with mathematics, it may be 2 times, but when it comes to the actual results and implementation, it may be 2.1 or 1.9 times better. So it's like roughly trying to quantify the difference between two techniques. So the next section is the results section. So this section is the base of the paper where you present the findings from your work. So this is the main base where we will be sharing our findings to others. So the experiment or the simulation results should be rigorous, extensive, and detailed. All the claims that we make should be backed by supporting results. So all the claims that we make in the previous section, in the body section, we should have a corresponding results for this. For example, if we make the claim that this technique is quite robust to temperature change, so we should be providing some results in this section. Otherwise, the reviewers are going to ask for this result. So we should be make sure that we have some results to support our claim. So good journal papers try to include minute details so that it can be recreated by others. So we need to explain the setup and the conditions in details so that people can recreate the setup and the condition and get back similar results. So depending upon the length of the paper, we can go in details. If the permitted length of the journal is more, we can give more details. So we should also mention whether the results are measured or simulations, specifically when it has both type of results. We should be very clear. So the best way is to read others' paper and find out the parameters they have used to validate their idea. So this is like, as I've mentioned, we need to read. So we need to have some sample papers. So those sample papers definitely will have different types of results or different types of parameters which they have used to prove their idea. So the next section is the discussion section. So in this discussion section, we try to compare our results or work with the state of art, of course, in a fair way. And it is best if you can provide an elaborate comparison table because the table speaks 1,000 words. So this is an example of an elaborate table. So these are the different references and these are the different details which it is trying to compare with the current work. So of course, whenever we are filling, we should make sure that this column should not remain blank. At least more than 50% should be filled because some paper may not report some details, so it may be difficult for us to fill it. So if this column is almost blank, then it is blank more than 50%, then it's better to avoid it. So the next section is conclusion. So conclusion, you try to write it point by point. Of course, we don't number it 1, 2, 3, but it should be point wise. So point 1, point 2, point 3. So in a running text, we should write it. And the conclusion should give a whole idea of our paper so that a reader can understand the brief idea of the paper without reading the whole paper. So after that, we have the reference section. So in the reference section, we should use the format asked in the particular journal, and we should try to include as many references as possible depending upon the length of the paper that is permitted. And of course, we should use both the latest and the old references. We should not just ignore the old references. We should have both the latest and also the old references.
So now we have understood the different sections of the paper writing. So the next question is, where should one start? Is it that I should start by writing the title of the paper or the abstract or introduction? So the point is where we should start. So we should start by writing the body of the paper and the results. This is because we have done the work and we have good results, we want to publish them, so we have this material. So this is the portion where we are most comfortable. So we should start filling the body and results. So it should basically start from results. Then once this is done, or at least some rough part is done, then we should start collecting the references that we want to put in the paper. So definitely when we are doing literature survey, we may have bunch of references, but we have to select the particular references that we want to include in the paper. And once this is done, we can slowly write the discussions and then slowly fill the introduction, then abstract, title, and finally the conclusion. So let's discuss some of the general writing tips. So the first tip is, as I mentioned, I would like to repeat that read before we write the journal. So we need to read good papers before we write. I suggest you should have a folder where you can have a collections of good papers. This is the practice that I followed personally. So when I was writing the IEEE Journal of Solid State Circuit paper, I was having a folder where I have collected good sample papers. So these papers were my ideal. I followed them in terms of writing the paper, drawing the figures or the presentations, etc. So the next tip is, a well-written paper gives the impression of a good idea. So if the paper is written very nicely, it will give the impression to the reviewer that the idea is good. So this is a statement by Professor Nota. Professor Nota was the editor-in-chief of IEEE Journal of Solid State Circuits. So this is another point he had mentioned, that if a paper is too complex, reviewers don't understand it, reviewers don't believe it, and reviewers will not like it. At the same time, if the paper is too simple, the reviewers will think, oh, there is nothing special, even if the results are good. So we need to make a balance between the complex and simple. So where do we balance? Which part to make the complex, which part to make the simple? So my suggestion is, or my observation is, the body of the paper, results, discussion, this can have a gradient of simple to complex then simple. So I'm representing it using this diagram. So the white portion represents simple and the red portion represents complex, and again the white portion, again it represents simple. So you should start with simple. The beginning of the body of the paper can be very simple, as we have mentioned earlier, simple to understand the motivation, and slowly as we go to the details, it will be complex. So definitely we have to go in depth and understand the whole concept in details, and definitely it will be a complex. Only the people who are expert in this area will be able to appreciate that. So, and then as we come to the end of discussion section, definitely will be simple, because we are trying to compare our work with others, so that's will be easy to understand. And definitely the introductions and abstract and conclusion, this would be a little simple. Of course they may have a jargon, but it's fine, but the language should be simple to understand. The next tip is, we should be quantitative, not qualitative. This we have discussed by giving an example of the SOP A and SOP B. So the proposed architecture consumes much lesser power than the conventional architecture. This is very vague. This is qualitative. This is not quantitative. Quantitative can be, the proposed architecture consumes 5 times lesser power than the conventional architecture. So the next is figures. So spend a lot of time to make good figures, such that the reader can understand the basic idea by looking at the figures and caption only. To make good figures, we need to plan it. It's not just about drawing, it should be about the planning. The figures should be like cartoon, right? So for example, in this diagram, I tried my best to make this figure stand out, And of course you can use different colors. The text should be very clearly visible. Of course it should not have too much details also, so that the readers get confused. Papers with bad figures almost always get rejected. Figures speaks 1,000 words definitely, but at the same time it is also necessary that we explain the figure elaborately in the text. It should not just happen that we just put a figure in the paper and we don't describe about it. So that is also not good. So if you are drawing figures and if you are using latex, try to create the figures in latex format, or that is EPS or PDF, so that there is no problem of resolution or file size. So this is an example of the figure in the EPS format. So you can see here, if I zoom this figure, even if I zoom it a lot, figure is not corrupted. So you can see it's very distinct. So the next point is we can use some softwares like Xarkit, Inkscape, Microsoft Visio. Xarkit and Inkscape are free versions which you can get it, and then you can draw very good figures. Of course there are multiple other options, and use MATLAB to draw graphs. So using MATLAB we can draw very good figures, and of course this can be saved as EPS or PDF format, and we can use different colors and different legends. And of course when we are drawing figures we should make sure that the labels should be clearly visible. The next is the language. The language of the manuscript should be clear and simple so that it is easy to understand. Use short sentences and simple words. Of course here and there you can use jargons. When you will be reading papers, definitely you will come across different jargons, so try to use that jargons also. 1 point per paragraph. First or last sentences of a paragraph is most important. So generally the other sentences of a paragraph are the details, but the first sentence is very important. If possible, let a native speaker correct your language or someone who is good in that. So take help of someone who is good in language to correct your language. So never submit a journal if it is half done. We should never be in a hurry to submit a journal. So submitting a half done journal is like feeding half cooked food to the reviewers. It will always be rejected. So if someone gives me a half cooked food, then definitely I will not be going to eat it. So that is same as submitting a half done journal. So the 3 R's before we submit the journal is revise, revise, revise before we submit. We should revise it multiple times till the point there is no mistakes remaining in the journal. We should keep revising. The next point is it is really annoying to read papers with mistake. So the reviewers will be annoyed when there is multiple mistake, and definitely they are going to reject the paper even if the idea is very good. And let your friend read your paper before you submit it, and take their comments also very seriously, because the comments made by them may be the same comments that the reviewer is going to give us tomorrow. So please take their comments also very seriously. So of course practice makes a man or a woman perfect. So as you keep writing, papers will become more and more better. And don't worry if your first paper gets rejected. It is seen that papers which were rejected initially are the most cited ones now. I hope this presentation will help you to get your first paper accepted. All the best. I suggest to go through this nice presentation by Professor Nauta, which I had mentioned earlier. So this is the presentation which he had made while he was the editor-in-chief of IEEE Journal of Solid-State Circuits, and I have taken many of the points from his presentation. If you have any questions, please feel free to comment. Thank you very much.